Okay, here's the problem solving video for problem 3.83. It says find V0 using mesh analysis. We're going to be utilizing the problem solving strategy on page 117. And to start off, we're going to assign mesh currents to the problem. And you notice we have three meshes. So we have I1, I2, and I3. So then in our problem here we have three unknowns, I1, I2, and I3. So we're going to need three equations. Now the only complicating factor here is that we have a dependent voltage source, and what we're going to do is we're going to write the equations and just treat the dependent voltage source as just a constant, and then once we write that equation, we'll express the controlling variable Vx in terms of the mesh currents and eliminate Vx from the problem. So let's start and let's apply KVL to mesh number 1. Okay, so that's this mesh. So let's start here and go around clockwise. We'll have a drop 2K times I1. Another drop that's 3K times I1. Then we'll have a drop that's 4K times I1 minus I2. Then we'll have 3K times I1 minus I3. And now we have this voltage source, 0.5 Vx. And then we have minus 10 equal to 0. So I wrote that equation just treating that 0.5 Vx as a constant. Now let's look at our circuit, and if we look at it, Vx is labeled there. If we look, we need the current in that direction, so Vx is 6K times I2 minus I3. So there's an expression for Vx. So what we're going to do now is let's substitute this in to this equation and simplify it. So let's see, we'll work on this equation some. We'll have 5K I1 plus 4K times I1 minus I2 plus 3K times I1 minus I3 plus 0.5 times 6K times I2 minus I3 equal to 10. And this term here, this is 3K times I2 minus I3. Now if we simplify this, we'll have 12K times I1 minus 1K times I2 minus 6K times I3. And that'll be equal to 10. Okay, so there's the first of our three equations that we'll need to solve for the mesh current so that we can solve for the voltage V0. Now let's do mesh number 2 next. Okay, for mesh number 2, if we start here, we'll have 4K times I2 minus 12, and as we come around, we'll have 6K times I2 minus I3 plus 4K times I2 minus I1, and that's equal to 0. So now, if we simplify this, we'll have minus 4K I1 plus 14K I2 minus 6K I3 equal to 12. Okay, So there's the second equation. Now, for mesh 3, we're going to apply KVL around it. Let's start over here. We'll have 6K times I3. And I'm going to treat this just as a constant for now. We'll have minus 0.5 Vx plus 3K times I3 minus I1. That's a drop across this. Then for this resistor, we'll have 6K times I3 minus I2 equal to 0. Now, let's make the substitution. So we're gonna work on this equation some now. So we have 6K I3 minus 0.5 times 6K times I2 minus I3 plus 3K times I3 minus I1 plus 6K times I3 minus I2. And then if we collect up terms, we'll have minus 3K I1 minus 9K I2 plus 18K I3 equal to 0. Okay. There's our third equation. So now we've got the three equations. Let's collect them in matrix form, and then let's solve them using MATLAB so that we can find the variable Z0. So in matrix form, our equations are the following. And you'll notice they're not symmetric anymore because of the presence of the dependent voltage source. Okay, so there are our equations. And now if we solve them using MATLAB, we get the following. I1 is 1.5644. I2 is 1.802. And then I3 is 1.1617. Okay, so there are our mesh currents. And now, if you'll remember from the circuit, V0 is 6K I3. So that's 6K times 1.1617 milli, which gives us an answer of 6.97 volts.